All right, hi folks. Thanks so much for the opportunity to be here. Yeah, as they mentioned, I'm the co-founder of a company called Two Bit Circus, which is a big band of nerds. And we're building this kind of ostensibly ridiculous thing. So before I tell you about that, I'm going to tell you about how we got here. I don't know how many of you have been in a failing startup. Turns out it's not fun. About 5 years ago, I was in a failing startup. We had decided to make a high-tech restaurant, touchscreens on all the tables, displays on the walls. You could order all your food from the screens and then play games against everybody. And that part was all really fun. The part that really sucked was we basically spent a lot of time and money building an iPad. And so we just sort of didn't really get the opportunity, the preparation right. We closed the last restaurant, and 6 months later, the iPad came out. And so that was too bad. So I was basically in this kind of meh stage of not being so psyched, and my co-founder, who wasn't my co-founder at the time, was at a think tank building robots to kill people. They were DARPA funded and whatnot, and he was also just sort of like meh. So we ended up meeting at this kind of hacker nerd drink up, and we started just saying, hey, let's collaborate on something. Let's have some fun. And so we started building interactive art. And so we would take computer vision and electronics and whatnot and put this stuff together just for fun and take it to parties and events. The first thing we did was this thing called Art Fall, which was basically a standard whiteboard. We'd point a camera at it and a projector, and you would draw on the whiteboard, and then circles and squares would fall and seem to bounce off the stuff that you drew on the whiteboard. Really simple, but really fun. People, at parties and whatnot, we're loving it, having a good time. And so we decided to make more stuff like that. So we started making lots of things. We challenged ourselves to make something new every single month. And we took them to more and more parties, and the parties started getting bigger and bigger. And this is a 6-player game table. Really simple graphics, right? That's just a light cycle game. But 6 is kind of a special number when you're talking about people playing together. You come to a party and event in groups of 2 and 4. 6 sort of guarantees that you're meeting somebody new, and instead of awkwardly like, hey, can I buy you a drink? It's, oh, I'm going to kill you next time, right? So we brought that, and so the parties started to even, now all of a sudden it wasn't just our friends saying, hey, would you bring that stuff to our parties? It was like Microsoft was calling, and Intel was saying, hey, would you bring your room full of laser beams over for us? And so we were like, wow, that's sort of interesting. This is a business? Wait, what? This was actually one of our spectacular failures. You can't really see what's going on here, but this was our version of Rock Band for space battle. So you basically had a pilot, a gunner, and a navigator in one ship, and then the same replicated next to it, and you basically had to destroy each other's space stations. Of course, flying around in space in all 3 dimensions turns out it's really hard, so that was not a fun game. Oh yeah, here's our room full of laser beams. Okay, one of the things that started to happen was this rock band found out about this big band of nerds in downtown LA, and they said, hey, would you guys help us make a music video? And we said, well, yeah, of course. So we did that. It was the guys from OK Go, and they said, hey, we want to be able to dance with a machine, and so we made that music video. It was a big 20,000 square foot workshop, and it started like this, and it ended like this. But what happened was, we had all these teachers and parents calling us saying, hey, that was so fun. We used that in our physics class, and it was really inspirational, and the kids made their own thing, and it's been this big learning tool. And we were like, what? This is a learning tool? This like crazy Rube Goldberg machine was something you used to teach? And that was sort of this like left-hand turn for us. We ended up also, this ABC TV show called and said, hey, would you guys invent stuff for us on TV? And we were like, well, we don't have TVs, but yeah, we're happy to come and help you. And the same thing happened. More teachers, parents calling, saying, hey, that was really interesting. You guys made this high-tech puppet show in this thing, and parents and teachers, again, they were like, wow, this is really neat. We made one of those in our class and started to play with this stuff. So earlier this year, we were sitting there, and we'd had sort of on one side this like high-tech amusement that all ages were really having fun with, and the other side, these sort of whimsical inventions that somehow were like a teaching tool. And so we decided to kind of slam those two things together into, let's see if this is still working. Actually, before I go there, so we got a big problem, right? You've all heard the term STEM, science, technology, engineering, and math, and this is the sort of rallying point for American policy around that. Really, us being really bad at that, right? I mean, we graduate a third of our kids into STEM degrees. It's like double that in China. We're at 48th, is our ranking in math and science. I mean, that's terrible, right? Really bad. And for us, there was a big discontinuity there because here we were having a ball being nerds and building stuff, and it didn't make any sense that kids didn't want to do that stuff too. And so we started going around to schools and we'd share with them that we'd build a big room full of laser beams and all this other kind of stuff, and the kids would just be like, what? No way. And we're like, well, the price of admission's engineering. And they were like, oh wow, okay, all of a sudden it didn't matter, right? So we took some inspiration from John Maeda, Harvey White, and said, okay, well, STEM is important, but art is also really critical, right? Art is the creative side, the thing that really woke up my co-founder and I back to loving engineering again, was making that kind of art and social fun. So we launched this thing called STEAM Carnival, not steampunk, STEAM, science, technology, engineering, art, and math. And so now I do literally say, to try to with a straight face, like, we're building a big crazy carnival. And people are like, what, you mean like an iPad app? I'm like, no, like a physical traveling event with people and freaking gear and fields and, I mean, it's a little goofy. But to share with you a little bit about the process here, because we believe in sort of surprising people into learning, right? Accidental learning. So the model looks like this. Well, so we launched a Kickstarter at the beginning of the year, and it ended up working well. So now this ship is sort of off and sailing. This is an over-promising illustration, but hopefully it gives you some idea of sort of where we want to go with it. But is really too much. The idea is two parts. One, a whole bunch of high-tech amusement, right? Lots of games, fun, the kind of stuff that all of us could go to and have a great day of concessions and amusement and never hear the word education, right? It should just be, it's a lot of fun. And then the second half is a stage show for kids to showcase their own projects, right? And we didn't want this to be another science fair with baking soda and vinegar volcanoes and all detestable stuff like that. We wanted to be stuff that the kids really found exciting too, stuff that they were proud to show off, and stuff that all of us, even if we didn't have a kid in the show, were going to enjoy watching, right? Enjoy being a part of. So we decided to hijack the things that kids already love: fashion, music, games, and then insert the engineering and the technology inside of that. So we have a whole bunch of project-based kits that the kids get to use in order to build their own projects. We've organized a big network of mentors from engineers at GE and researchers at Children's Hospital and talks with a bunch of other tech companies, so that those kids can then be connected with those mentors for stuff that they don't understand. So the model, if you can read that, day one, in any given city, we deploy one of our people. They go around to a bunch of schools. They train up an administrator on how to administer our kits, where to contact the various engineering mentors. The kids then get 10 weeks. They get to build their own thing. So now they're building their own wearable electronic. They're building their own musical robot. And then they know that at the end of the 10 weeks, the carnival comes to town. They're going to get to play all the games, and they're going to showcase their stuff. So there'll be a fashion show of wearable electronics. There'll be a concert of musical robots, and there'll be an arcade of indie group games. So here's a couple. We've been testing. So ever since, we've been testing a bunch of this stuff. We got a big workshop in downtown LA. We open it up for big art walks and have kids and families and whatnot all come in. This is a kid playing basically a laser projected version of Asteroids, where he's the ship. And so we're doing with a laser rangefinder. We're tracking where the kid is. He moves around. He's avoiding the asteroids, and then he's got a Wiimote in his hand so he can shoot the asteroids. A lot of fun. These kids. We're using a big circus ball here. Mounted on casters to be able to control a digital skee-ball game. This is a big wall of buttons. This is actually an older version. Turns out people get their fingers caught in the gears, so you gotta kind of build those things to figure that out. So we got another version that's not as dangerous. But my favorite part is, in addition to the kids getting to play all the games, the day of the carnival, we show them, we reveal to them how we make all of our stuff, and turns out it uses all the same materials that are in the kits, so that the kids get to see, wow, not only can I make the things that I've been playing with for these last 10 weeks, but I can do all this other stuff. And in fact, there's mini versions of our things. You know, rather than say a big wall of buttons like this, there's a little one that you can build, you know, in your living room. And we have ours almost really as just sort of a demonstration of what is possible with these sorts of things. So that is the end of what I was going to say about the carnival. We do have some kids that have been working on their own version of one of our earliest kits. We're going to do a little mini fashion show for you guys right now. Oh, yeah, sure. So our wonderful curriculum expert, Elise, right here. Everybody give Elise a big hand. So we've been working on a whole bunch of different sort of versions of this stuff as we explore the space. Elise been working with them on our sort of 45-minute workshop, which is a little introduction to electronics. They've got some fiber optics there, some copper tape, and they've built their own little light-up headbands. And so at any rate, we've got a whole series of these different things. This is the earliest version of them. We've got another one that's a musical synthesizer, where kids get to learn about capacitors and being able to make digital music. At any rate, a lot of fun.